Hello everyone, and welcome to our first video about set theory. In this video we're just going to talk very briefly about what a set is and some pretty basic concepts about what we can say about a given set. So we're going to start out by talking about this room full of people here: Marge, Bob, Jim, Sophie, Sam, and Leah. And we know some things about these people that make us want to say something about some of them, right? So we know that some of these people are students. So we're going to circle the 3 of them that are students right here. Jim, Bob, and Marge are students. Sophie, Sam, and Leah may have other things about them we don't know about them, but we know that Marge, Bob, and Jim are students, and by saying this, we have put them in a set. This blue circle here is a set. All that a set is a circle drawn around some things, right? All that a set is a circle. That's the best way to think about a set. Now, mathematically, we want to talk about this. We want to be able to define a set in some way that's sort of formalized, which is what we do in math. And this is usually how we do it. First, we give our set a name. So this set, because it's a set of students, we're going to name set S. And then we put equals, because this tells us who is in the set. And then all the members of the set are in the set, which is defined by curly brackets. Right, these sort of curly brackets. And they're separated by commas. Right, and that's how we list the members of a set. Right, now notice that because a set is just a circle, that's all that a set is, we can define the set in any order we want. So the set containing Jim, Bob, and Marge is the same as the set containing Marge, Jim, and Bob. It's the same 3 people, and it doesn't matter what order we list them in because it's just a circle placed around those people. Right? Does that make sense? It also means that to list anything in your set twice really is basically meaningless. Right? So Bob, we've already circled Bob, so why would we say that Bob is in the circle again, right? You're allowed to do it. It doesn't change the meaning of your set, but it also doesn't give you anything more interesting about your set. So these 3 sets are all the same, right? So our original set is the same as our set that has been reordered, which is the same as our set where we have added somebody else's name in here, right? If we did live in a world, because I know somebody's thinking this, if we did live in a world where there's 2 Bobs, right, this happens to be Bob too. If we want to put either one in our set, we're going to have to give them, some additional, we're going to have to change their name, right? So if we want Bob 1 to be a student and Bob 2 is not a student, right? So each of these things is a unique instance of Bob, right? So this is a unique instance of Bob that happens to be a student. Okay. Now let's move on to a couple more things about the really basics of sets. So in this example, we're going to make a set of something else. We're going to make a set of letters, and we are going to put X, Y, Z, and J in our set. Now so in our first set, we had something that these things all had in common. They were all students, right? In this set, we're not going to specify anything that they have in common. They just happen to be in a set together, right? You can make sets of anything you can circle in your mind. Concepts, letters, anything you can circle in your mind can be put into a set. And since these all happen to be letters, we're going to call this set L, which is made up of the members X, Y, Z, and J. Now, if we want to say something about X, we can say that X is a member of L. That's what this symbol means. It means that X is a member of L. And that's what we call anything that is inside a set is a member of that set, right? So anything inside a circle is a member, right? We can also put an X through that symbol to say that B is not a member of L. So this little symbol is a very important symbol. This is the symbol that symbolizes set membership. All right, we're going to do one more thing with sets in this video, and then we'll move on to more fancy ways that we can describe sets. In this one, we're going to use colors and make a set of different colors. And this set is made up of these colors, which we have defined as a set. Set C for colors is made up of blue, purple, red, and I think this was supposed to be green, but it doesn't hardly look green anymore. Now, you can see that this set has 4 members, right? There's 4 things that are in this set, right? 4 colors in this set. And that means that the set has a cardinality of 4. So the cardinality is the number of members, right? Cardinality of C is the number of members in C. And in this case, the cardinality of C is 4. And if you're looking to ask somebody what is the cardinality of a given set, we put it between these straight lines, and that means the cardinality of this set. So we have now gone through all the really basic stuff about what a set is and how we think about membership in a set. One thing that we didn't mention, usually sets are defined using capital letters, but there's no real reason that has to be. You usually give the set a name, a capital letter. All right, so in the next video, we will talk about some fancier ways that we can describe the members of a set so that we maybe don't have to list them all. So tune in for the next video.